All right, this is 9.4, Algebra 1, 9.4, solving quadratics by factoring. Hey, I'm going to just review things that we talked about last time and roll through a couple of examples from each one of these. But the very first thing that we talked about with 9.4 was the square root property, which basically just says that you can take the square root of both sides. That's all this is saying. So if you have something squared equal to some number, you can simply take the square root of both sides. Okay, so in short, you can take the root of both sides if this is the case. If you have one thing squared equal to some number. What that means is if you have something like this, x plus 6 squared equals 81, I could take the square root of both sides and solve for this thing. And then just remember, when you do that, whenever you take the square root of some variable, we have to consider the fact that that could be positive or negative number that was in there. Because, negative 3 squared and positive 3 squared both give you 9, right? They both equal 9. So we have to consider the fact that it could be a negative. So when I do this, when I take the square root of both sides, this just cancels and I'm left with x plus 6. And on the other side, I am left with the possibility of a positive or negative 9, because the square root of 81 is 9. Okay, and then I just solve for x. To solve for x, I'm just going to subtract 6 from both sides. So x would be equal to negative 6, right, because I subtracted 6 from both sides, plus or minus 9. Negative 6 plus 9 gives me 3. Negative 6 minus 9 gives me, negative 15? Negative 15, and I'm done, right? So that's how you would use the square root property. All right, so, and make sure these are not coordinates, right? These are individual answers, because remember what we're doing, you guys. We're finding the places where the graph crosses the x-axis. This is an x equals. I'll let you play with the other examples there, but I want to move on to the zero product property. Zero product property, we mentioned this one as well, is what makes each factor go to 0. Okay, this is the reason we factor, you guys, because when we factor, we can create something that we can look at very quickly and determine where the zeros are. Okay, so that's why we factor, one of the big reasons. So for example 3, what's nice about the first one they gave us here is they factored it for us. This is already factored, right? If you were to FOIL this out, don't do this, but if you were to do this, you would get 3n squared plus 6n. This is more complicated, in my opinion, than this, just because I can't determine what the zeros are very easily from this, right? So we're looking for things in factored form. This is already factored, right? So now, once I know that something is factored, and oftentimes they're going to make you factor it, I look at each individual piece. What makes 3n go to 0? Like, what can I plug in for n to make that equal 0? Because the zero product property says that whatever makes a factor go to 0 is where, because technically, you guys, this is equal to y, right? It's where the y is equal to 0, right? So if a factor equals 0, I know that I have a crossing, right? A crossing on the axis, on the x-axis where y is equal to 0. So, and the reason for that is, if you have something equal to 0 times something else, you're always going to get 0. And where y is equal to 0, I have an x crossing. Okay, so in this case, what would make this go to 0 would be 0. And then if I look at this one, n plus 2, what makes that go to 0? Well, you can solve it for 0. Subtract 2 from both sides, n is equal to negative 2. So if I plug a negative 2 into this factor, I would get 0. So here are my two possibilities, and I'm done. I'll do one more of these with you guys just because that one was factored for you. The next one is not. So here, I have to factor it first. So very first thing I do, especially if there's only two terms, is ask, is there anything in common in both pieces? And the answer to that is yes, there's an a and a b. And if I take that out, I'm left with b minus 5. Okay, so what makes 8b go to 0? Hopefully you're seeing that that's 0. And what makes this thing go to 0 would be 5. All right, for 3c, we're going to move this guy over, right? So we have x squared plus 10x equals 0. And when I do that, I have an x in common, and I'm left with x plus 10. All right, so 0 makes that go to 0, and negative 10 makes the other one go to 0. All right, so that's example 3. This is just reminding you guys of the different types of factoring: distributed property, grouping when there's 4 or more, quadratic trinomials, that's just regular factoring with 3 terms. Perfect squares happen when you have 3 terms where we have, remember that it's the first term is perfect, the last term is perfect, and the middle term is 2 times those roots. 2 times those roots. And then we have and don't worry about this one. This one's not a big deal if you don't remember this one. It's more important that you know this one. Then the last one's the difference of squares, right? So if you have 2 terms like this, x squared minus 9, it's always a difference. This is a perfect square, this is a perfect square, so I can write that as the factors would be x plus 3, x minus 3. Remember, because we want the middle term to cancel out. Okay, so it's just the root of this plus or minus the root of that. So those are just some reminders from last chapter, but let's move on. For example 4, we have 2 terms here. Okay, so I'm going to look for a difference of squares. This is definitely a difference. This is a perfect square, this is a perfect square. So I can write this as 7 minus x, 7 plus x. Okay, difference of squares. All right, so what makes the first factor go to 0 will be 7, and the second one will be negative 7. Okay, for the second one here, I'm going to go ahead and move the 45 over. Okay, so if I do that and move this over, this is 0. And then this one would go to 36, I believe. And then everything else kind of stays the same here. Okay, so then I'm noticing something here that's going to give me a big shortcut, okay? Hopefully. This is a perfect square. It can be written as something squared. So can this, something squared. And I'm hoping that this middle term is equal to 2 times those 2 factors, okay, for a perfect square trinomial to give me a little shortcut. So this thing would be the same thing as 5y squared. 5 squared is 25, y squared, right? And then this one would be 6. So what I'm hoping is that this is equal to 2 times 5y times 6, those 2 pieces. And it is, because 5y times 6 is 30y, 30y times 2 is 60y, right? So we have this negative sign that we have to consider, but it is. So this thing is a perfect square trinomial. Okay, so what I'm going to do is I'm going to take the root of the first guy, 5y, and I'm going to take the sign that's given right here, minus 6, and I'm going to square that. Okay, that's my answer. What makes it go to 0? Sorry, that's not my answer, that's my factor. What makes that go to 0? Good question. What makes 5y minus 6 equal to 0? Okay, so we can solve this. All right, and we get this guy. So y is equal to 6/5. So my answer here is 6/5. This is one of those ones, since it's perfect square trinomial, where we have a vertex that hits the axis, so it only touches in one spot, and it happens at 6/5. All right, so for 4c, kind of similar, but we're going to just do a regular factoring here, I think. So we're going to add 21 to both sides. We get 0 here, we get 36 here, negative 13x, x squared. Okay, so what 2 things multiply to give me 36, add to give me negative 13? Okay, so let's look at our factors of 36. 1 and 36 doesn't work. 2 goes into 36. What is that, 18 times? That doesn't work. 3 goes into 36 12 times. Okay, getting closer, that still doesn't work. 4 goes into 36 9 times. And there we go. 4 and 9 can give me 13 somehow. So it would have to be negative 4 and negative 9, right? So I can factor this as x minus 4, x minus 9. If you want to be sure, you can FOIL it back. Right? X times x, x squared, minus 9x, minus 4x, plus 36. Okay, it works. Okay, so the answer to this is whatever makes these go to 0, right? So what makes that go to 0 is positive 4, and what makes that one go to 0 is positive 9. All right, so that's example 4. And I think that's all we had, you guys. just look at your books here. Example 5, I don't think I'm going to go into. It's not as important, where it gives you coordinates and has you come up with these. So I'm not going to even give you any homework related to example 5. We're just going to stop at example 4. So there's a video that help you do 9.4. Have a good day, guys.